Hey everyone, welcome. Today I'll be showing a complete demonstration of our async-mariadb-connector, which is a high-performance asynchronous library to connect, query, and manage MariaDB in Python. Today I'll be lightly coding in this particular main.py file. The script will show off all major APIs, starting from query execution, streaming, connection polling, and Pandas integration. So all with asynchronous. Let's get started. So for your kind information, I'll be sharing this repository link in the description. You can clone it and work with it with the following setup procedure. So before writing the code, I will show you .environment files. I'll show the example one where my original .env is exposed to some passwords. So that's the reason. So here you can see the database configuration as well as connection pooling settings. So what is connection pooling and what are the settings? I'll explain you while showing the output. Okay. And for the configuration, you need to choose this. You need to enter the port, use any password, what's the DB name you're supposed to use. Okay. Now. So what the requirements.txt file is. So for this, we're keeping this minimal. Okay. So we'll be using Pandas library, and for importing this environment files, we'll be using python.env, and also we'll be using our main library async-mariadb-connector. Okay. Now let's start coding. First, let's add a short description. Yeah. Let's add a short description of what actually our project is. What the script does. So which showcases this particular script showcases all major APIs and features in a simple workflow. Fine. Okay. Now let's start with the import. So we'll be using async library. I'll explain why. Async library is used to run our async code, and from path import path. Fine. Fine. So from the asynchronous MariaDB connector, we're going to import a few things. The first one is async MariaDB. Searchable option fine. From seeing async MariaDB, we're importing the same bulk insert. We're going to import bulk insert. Fine. So we're importing async-ivo to run the synchronous code and .env to securely load database credentials from .env, and Pandas we're using for the DataFrame operations, and our own asynchronous MariaDB connector for the database handling errors and bulk operations. Fine. Now let's load the .env from the current folder. This avoids exposing sensitive credentials like passwords inside the code. We all know that. So what I'll be doing, env path. I think the system is lagging. Yeah. So from this parent directory, we're going to load .env. Fine, that's fine. Fine. Now let's load the environment. Yeah. Simple, still system seems slightly lagging. Okay, yeah, fine. So what actually this does, this line dynamically loads .env located, which is located in the same folder as the script folder. You can see here, right? These are located in the same folder. Okay, now let's start the asynchronous function. We define our main async function now, and where all the operations happen. Fine. Fine. So I'm going to print the title, which is basically this is okay, starting example workflow. Fine, that's fine. Print. Yes, we have connected to the database. Before that, what let me do is, let me also print the pool stats right. Pool stats, and for your kind info, we have this API called db.get pool stats, which gives us the pool stats. Fine. Fine, right? So this uses an async context manager to automatically manage the connections. So open when entering, close gracefully when done. The pool stats which we use here shows us how many connections are active and available. Okay, I'll explain a little detail about this connection pooling when I'll explain the output. Okay, fine. Now let's start clean. Drop the table if it exists and create a new one. This demonstrates the execute API, which runs SQL commands like create, drop, update, or delete. Fine. Wait. Shit. Execute. So we use drop table if exists demo users. Fine. So now let's create a table. Fine. So here let me do is create a table. Demo users. System is lagging. Now, what this table should contain? This table will be having an ID, which is int. Let's add auto increment there, which is also primary key. Fine. Along with that, it has a name, password, email, age, and yeah, let's use this recommendation. And finally, let's close. Let's close this. Now, let's print create a table demo. Yeah, fine. This recommendation is fine. Next, what we are going to do? We're going to create an users where simply lies for the email. Let me use lies at example.com, and let me make just 25. Fine. In a similar way, let me use a recommendation to expand this particular users. Okay. Yeah. Okay. Similarly, let me create it for Bob and recommendation. Let me go with the recommendation. Okay. And Charlie, fine. What this recommendation says, Charlie dot example. Fine. Let me also take. Okay. Yeah. The recommendation is fine. Okay. Okay. That's it for now. The four tables. The four records. Okay. Now what let me do is, okay, wait. Let me execute this using the own execute many command. Execute many command, which helps us in insert into demo users. What we should be inserting? Name, email, age with values. We had arrow. So the command is recommendation is correct. Fine. Users. Fine. That's fine. Okay. Now the system is lagging. Sorry for that. Yeah, a small typo. A typo here. Insert. Fine. That's fine now. Yeah. So though it seems like something. It is showing some letter not closed. Really? Yeah, it's closed here. Now let me print. Now what let's do is to data use that all again. It returns all results as a list of dictionary. Each represents that. Okay. Now use this command should be within this inverted commas. Okay. So that's fine. Now let me print this by let's use this. Oh, this is fine. What and now what I do is for fetching just one record, the username values, we can use the fetch one function. Let me also repeat that. One user is equal to we have this equal to where thing is equal to fine. The command the recommendation command is fine. Right? Yeah. Now let's print the test. Okay. Now, if you're working with large data sets, so we can use fetch string to stream results asynchronously. We keep memory usage minimal. Rows are fetched to one at a time. Okay. Let me do that. String users. Okay. Fetch string. Okay. So here select all from memory. Yeah, that's fine. And now here we're printing the report. We should have some cancels. Fine. That's fine. That's fine. So one of the coolest features is fetch forward here. Like what it is, which convert SQL query results into a Pandas data frame, which is great for analysis and reporting. Fine. So now data frame is equal to wait dot the API name is fetch all df. Not sorry. Here select all from the that's fine. Sorry for that. Yeah, that's recommendation. So you're going to directly print that. So now let's create and put a batch of users from an external CSV file or API. Like we'll create a Pandas data frame and use our bulk insert utility to put all rows efficiently into this database. Okay. Now, I'm creating a data frame. It's new SQL start data frame. Basically, the continuous things. Okay. Now what I'll be doing is bulk inserting this. We had this method array called bulk insert. I'll be giving a DB and demo uses and new data frames, right? Now let me print a bulk insert from data frames. That's fine. So, now finally, let's monitor the connection. Let's check our connection pool start again. Before infeeding and after getting, let's check how it checks connection pool is. Okay. For this, let me print pool stats and pool stats. Fine. Right. Now, finally, let's close this connection. Once the block complete, the context manager automatically releases all the connections. We also handle specific connection issues. Very problems about failures. Okay, we'll use the next. For that, print connection closed. Context manager exit. Okay, I'm going the right way. Yes, that's done. So I forgot this. Please, you don't do that. Okay, that's fine. So now, if you can observe that we had a try hit try block here, right? So matching except blocks also be there. So here comes how we going to handle. So what if suppose it's a connection error? It can be anything, right? So we can have different except blocks and print different errors. So for one of the time constraint, I'm going to use a simple error occurred and print it, right? That, yeah, fine, that's fine. Okay. Yeah. See, what's that? Oh, I should do this. Yeah, no, it's not. So now finally, let me print. Yep, it's done. Demo completed. Right. So finally, we use async.io run to start our asynchronous workflow. This doesn't make our library async. It just launches the event to run asynchronous functions. Okay. So fine. Let's put that run. Fine. That's fine. And that's it. We just demonstrate every major feature of async-mariadb connector from connection pooling and express operations. Now let me run this and check. Let me check. Are there any errors? So let me run it. Yeah. You can check the output now. Let me back this. That's fine. Yeah. So this is the title which is yeah. So first, our library first creates a connection pool. Okay, I will see what actually pool means here. I told you, right? Yeah. So our library first creates a connection pool to the MariaDB. So what actually pool means is multiple reusable connections to the database, so that you don't have to open or close connections each time you wanted to use it. So which improves performance. So you can see the stats here. What the stats says? The size is 1, max size is 10, minimum size is 1. What the size says? The active connection in the pool. What's the max size 10 says? Maximum of 10 connections are allowed. And what does available says? One free connection is ready to use. Why it is saying one free connection is ready to use? Since we hadn't used it, this particular pool stats are printed before the starting of the application, right? It is before starting the code. Well, we had a demo user table created, and then batch insert is completed, and we also fetched the users, right? These are the user names, okay? And we also stream it using fetch stream, right? So this is what it is. So this result shows like fetch all rows. It's a typical JSON format, which is ideal for APIs or SMS applications. So we also fetch a single user, it seems. Yeah, we also fetch it using fetch one. And for streaming purpose, streaming queries, this demonstrates like data is fetched row by row instead of all at once. You can check here how it is fetched by row by row. It's great for handling like large data sets efficiently without consuming too much memory. Okay, so now the data frame conversion is happening here. This shows that our library can also return results as a data frames. See how beautiful that becomes. Right. So like making it convenient for data analysis and visualization. This is especially for data science workflows. We also show the bulk insert from data frame, right? It shows like starting bulk insert of 2 rows into data table. So it is also completed successfully. After this, we are seeing this pool stats now. After all operations, we check the pool set again. It confirms that all connections were correctly released back to the pool. After it is utilized, again it is released. Now again it is available. One connection is again available. Okay, which means that no leaks and clean resource management is happening. Okay, so connection is closed. The connection pool is automatically exited. This ensures a safe cleanup and is a best practice for asynchronous database operations. And finally, our demo is completed. So this marks the successful completion of the demo, showing that every key functionality of our library works perfectly, starting from async connection pool, table creation, batch and bulk insert, data fetching, data from degree or cleanup, right? So how it goes on, like start creating a connection pool to MariaDB, then create the demo table, perform the batch inserts, fetch data in different ways, streams results row by row, converts them to Pandas data frame, and even perform bulk inserts from a data frame. And at the end, the pool is closed safely, showing that our asynchronous connection management is clean and efficient. So this is a project asynchronous MariaDB connector. Thank you. Again, the system is getting lagged.